The universe is vast and dark, and for most of history we glimpsed it with only our eyes and simple telescopes. Each new tool revealed more of the cosmic story, but now we have the James Webb Space Telescope, JWS. This isn't just another telescope, it's a golden honeycomb of mirrors a million miles from Earth, built to look back in time. JWS peers through cosmic dust and infrared, capturing the universe's baby pictures, the first stars and galaxies after the Big Bang. Hubble showed us the universe in its prime. JWST lets us witness the cosmic dawn. Its engineering is astonishing. Folded like origami to fit a rocket, it unfolded itself perfectly in space, shielded from the sun's heat by a tennis court-sized sun shield. JWS must stay cold to detect faint heat signals from the most distant objects. Any warmth from the sun or Earth would blind it. With this instrument we search the darkest patches of sky, hunting for the faint red smudges of the first galaxies. Scientists worldwide held their breath as the first images arrived, postcards from the edge of time. We saw galaxies and star-forming regions in breathtaking detail, finally getting answers to our biggest questions. But then, JWS saw something else. Something that didn't fit any of our models. It was unexpected, a signal that sent a shiver down the spine of the scientific community. The universe had just handed us a new mystery. This wasn't just a new discovery, it was a challenge to everything we thought we knew. The search for answers had only just begun. JWS's golden eye had glimpsed something impossible. What could it be? The world of science was about to be turned upside down. Our understanding of the cosmos was on the verge of a revolution, and it all started with a single, inexplicable signal. The story of UHP-19b was about to unfold. The discovery began quietly, deep in a data center, as astrophysicists analyzed a long-exposure image of empty sky. They searched for the oldest galaxies, collecting faint light and sifting through cosmic noise. For weeks, the data looked normal, until a young astronomer noticed a flicker. In one corner, an object pulsed, not glowed. At first it seemed like a glitch or interference, but every test confirmed the signal was real. It came from the edge of the observable universe, just a few 100 million years after the Big Bang. The signal wasn't random, it was a perfect, repeating pattern, a cosmic heartbeat, regular and impossible for that era. The team worked in secret, triple-checking every calculation. The object, UHP-19b, was in a region where no complex structures should exist. The early universe was chaotic, a soup of gas and young stars. Nothing should pulse like this. Even if a pulsar had formed, its signal would be too weak and scattered to detect. This was something new. The realization brought not celebration but confusion and awe. Imagine hearing a drumbeat in a silent room with no source in sight. That's what the scientists felt. They had found a signal from the dawn of time, and it didn't fit any known pattern. The universe had just whispered a secret. The search for answers was on. What could create such a pulse? The implications were staggering. Science was about to face its greatest puzzle yet. JWST detected a light source turning on and off with a precise, unwavering rhythm every 7.7 hours. Such regularity is shocking. Nature, especially in the early universe, is rarely so perfect. Finding this is like discovering a smartphone in a dinosaur fossil bed. It shouldn't exist. Our cosmology says complex, stable systems come much later, not just after the Big Bang. UHP-19b disrupts that timeline, suggesting organized phenomena appeared far earlier than believed. The energy of the pulse was immense, outshining entire galaxies during its brief flare. No known natural process fits. Supernovas are one-time events. Pulsars spin much faster, and binary stars don't match the light signature. Every explanation failed. The real fear isn't monsters or aliens, it's that our understanding of the cosmos is fundamentally wrong. It's like a bridge vibrating in ways physics says are impossible. There's a gap in our knowledge, a hole we never saw coming. The universe, it turns out, doesn't have to follow our rules. This anomaly is a wake-up call. We must rethink what's possible. The mystery had only deepened. What makes this heartbeat so baffling? Pulsars pulse quickly, milliseconds to seconds. UHP-19b pulses every 7.7 hours in a class of its own. Quasars flicker, but not with perfect regularity. Eclipsing binaries create dips, not massive spikes of energy. UHP-19b's pulse is a sudden blinding flare, not a simple blockage. Its light spectrum doesn't match any known star or object. It's too slow for a pulsar, too regular for a quasar, and too energetic for a binary system. It fits no known category. This is thrilling and unnerving. Centuries of cosmic classification, and now, something that breaks the mold. JWST has shown us an animal the books say cannot exist. The regularity suggests a stable, repeating process, but nothing in our cosmic zoo matches it. We're left with a puzzle that challenges the very foundation of astrophysics. The universe has revealed a new kind of heartbeat. What could possibly cause it? The search for answers is more urgent than ever. Science thrives on such mysteries. Past discoveries, Galileo's moon's Hubble's galaxies, expanded our view but fit within known physics. UHP 19b is different. It suggests the map itself may be wrong. It's not just a new dot, but a question mark over the entire map. When pulsars were first found, we soon understood them. Here we have no model. It's as if the signal spelled out prime numbers, utterly inexplicable. This opens the door to new physics, exotic objects, unknown energy processes, or even dark matter interactions. It forces humility. Our cosmic catalog is incomplete. The discovery is a call to rethink everything. We may be on the verge of a revolution in understanding. The universe just got a lot stranger, and that's the most exciting part. What could UHP 19b be? Ideas range from new types of stars like quark or strange stars to exotic black hole pairs in improbable orbits. Each scenario requires physics we've never seen in the early universe. Some propose even wilder ideas: decaying dark matter, cosmic strings, or phenomena beyond the standard model. These are Nobel-level discoveries if true. And, inevitably, the question of intelligent life arises: a beacon, a galactic lighthouse. Most scientists are skeptical, but the regularity and power make it hard to dismiss. The universe is vast. We'd be arrogant to think we're alone. The team's first reaction was disbelief, then intense scrutiny. Dr. Evelyn Reed, lead astrophysicist, tried to prove it wasn't real. Every test made it more undeniable. The discovery is both a theorist's nightmare and an observer's dream. Once published, the scientific community erupted. Debates, emergency conferences, and new theories. Some proposed complex natural explanations, like a blazer's jet twisted by a massive companion. Others admitted we might have found something fundamentally new. UHP 19b is a lesson in humility. Our understanding is just one chapter in a much longer book. Theoretical work exploded, but skepticism remains. Astronomers want more data, more observations, and ideally another object like it. One anomaly is a mystery. Two is a new class. For now, UHP 19b is a beautiful, unsettling outlier. The discovery is just the beginning. JWST will stare at UHP 19b for weeks, testing the pulse's stability and spectrum. Astronomers will hunt for more such objects, reanalyzing old data and designing new searches. If more are found, our understanding of the early universe will need rewriting. The search now unites cosmologists, particle physicists, and even SETI researchers. SETI will analyze the pulse for any sign of information, a message, however unlikely. The question, "Are we alone?" has never felt more urgent. The race for answers is on. This is why we explore, not just to confirm what we know, but to be surprised. JWST's discovery is a reminder: the universe is under no obligation to make sense to us. Whether UHP 19b is a new kind of star, a black hole dance, or something stranger, it has already expanded our horizons. Science isn't about having all the answers, but about living in wonder and refining our questions. The awe will remain, even as confusion fades. The night sky holds secrets we haven't dreamed of. As our golden eye keeps searching, let's embrace the unknown. The universe has whispered a new secret, a puzzle to solve. The journey will teach us more about the cosmos and ourselves than we ever imagined. Keep looking up.